Hello students, here in this video we will see the topics of dynamics of particle, relationship of velocity, acceleration and displacement tutorial problem 1. Let's go for the problem. In last video we will see the problem 1, this is the problem 2. A bullet moving at the rate of 250 meter per second is fired into a log of wood. The bullet penetrates to a depth of 40 centimeter. If the bullet moving with the same velocity is fired into a similar piece of wood 20 centimeter thick, with what velocity would it emerge? Emerge means in what velocity the bullet come from that 20 centimeter thickness wood. Take the resistance to be uniform in both the cases. Okay, let's go the solution. In first case, uh, initial velocity of the bullet. Okay, initial velocity of the bullet is 250 meter per second. The final velocity is 0 because in 40 centimeter depth the bullet is penetrate, but it will not come out from that wood. Okay, the bullet is not coming out of the wood, so bullet will rest. Okay, completely rest, so final velocity is 0. Okay, distance moved by the bullet before coming to rest is 40 centimeter. The depth is penetration is 40 centimeter. So 40 centimeter is converted into meter. So 10 into 40 into 10 to the power minus 2 or else 0.40 meter. First calculate the retardation of the bullet because uh, the velocity is higher to lower. So here acceleration will be reduced. Okay, negative acceleration. So we have to find the retardation. Okay, here we using the this relation because we know the final velocity and initial velocity and also the distance. Here we have to find the acceleration. So with this equation we will find the acceleration of the bullet. Okay, so okay, here the final velocity is 0 and initial velocity is 250 meter per second, and distance is 0.4 meter. Okay, apply this value in this equation and resolve this equation. Okay, uh, here a equal to minus 250 into 250 square or else 250 square divided by 2 into 0.4. Okay, using this solve this equation we will find the acceleration is minus 78125 meter per second. Retardation value is 78125 meter per second square. Okay, in second case this is the first case. Okay, the acceleration of the bullet is, in the first case the acceleration of the bullet is 78125 meter per second square. Okay, now we go to the second case. uh, Initial velocity of the bullet is, here the bullet is moving with the same velocity, so the initial velocity of the bullet is 250 meter per second, same as before. Okay, distance moved, here the bullet is moved in 20 centimeter thick of wood, so distance is 20 centimeter. Okay, centimeter is converted into meter, so 0.2 meter. As the wood is similar and also resistance is uniform. The question is given the resistance to be uniform in both the cases. That means resistance, the same wood material is used here. So the wood is similar and also resistance is uniform. The acceleration will be same as in the first case. So the material of the wood is same and resistance of the wood is same. So because the acceleration of the bullet is also same. Okay, so acceleration A equal to minus 78,125 meter per second square. Okay. Now using this equation, you will find the final velocity of the bullet. Okay. Okay, you find the final velocity of the bullet v. Okay, we know the initial velocity 250 meter per square, and acceleration is 78.25 meter per second square, and s equal to 20 meter 20 centimeter. Using this equation, we will find the final velocity. Okay, here let v equal to final velocity, not u. This is the v. Okay. Now using this equation, v squared minus u squared equal to 2as. Here u equal to 250 squared into a is minus 7825 meter per second squared into s equal to 0.2. Okay, apply all the values into this equation and resolve this equation. You will find the value of final velocity 176.77 meter per second. The bullet is passing emerge out from the 20 centimeter wooden piece with a velocity of 176.77 meter per second. This is the final velocity of the bullet in the second case. Okay, and let's go for the next problem. On a state road, a smuggler car passes on a police station with a uniform velocity of 10 meter per second. Okay. After a 10 second, a police party followed in pursuit in a jeep with a uniform acceleration of 1 meter per second square. Find the time necessary for the jeep to catch up with the smuggler car. Okay, here two things are given. One is uniform velocity of the smuggler car, and after the 10 second only the police car will be started from the station. Okay, after the 10 second only the car will be started from the police station. And here the police jeep acceleration is uniform acceleration is 1 meter per second square. Okay, for smuggler car is 10 meter per second. Here they are given in velocity, here they are given acceleration. Okay, now we have to find the time necessary for the jeep to catch up with the smuggler car. In what time taken for the police party to catch the smuggler car? Okay, this is the question. Let's go for the solution. Okay, here uniform velocity of the smuggler car is 10 meter per second, and uniform acceleration of the police jeep is 1 meter per second square. Here the acceleration, here is the velocity. Okay, let s equal to distance from police station to the point where the police jeep catch up the smuggler car. Okay, and time t equal to time taken by the smuggler car to cover the distance s. Okay, uh, t dash equal to time taken by the police party to catch up with the smuggler car to cover by the up to the distance s meter. Okay, distance. Okay, here t dash equal to t minus 10 second, because the police jeep is started after smuggler car is passing from the station. After 10 second only the police jeep is started from the station. So is total time taken by the smuggler car to cover the distance. Yes, after 10 second only the police party will start. So t minus 10 second, this 10 second, sorry, this 10 second will be subtracted here. Okay, now first consider the motion of smuggler car. Okay, the smuggler car is in the uniform velocity equal to 10 meter per second. Okay, distance s is s covered in the time is given by s equal to u plus u into t. Okay, the uniform velocity. So we use this relation, distance s equal to u into t. Here the uniform velocity is equal to 10 meter per second. So 10 into t. This is taken as a equation 1. Okay. Now consider the motion of the police jeep. Okay. Acceleration is 1 meter per second squared. The initial velocity of the jeep is 0 because the jeep start from the rest. Jeep is start from the rest position. Okay, rest position only it will start. So the initial velocity is equal to 0. Okay, distance equal to s and time taken for police jeep to cover the distance. Okay, t dash equal to t minus 10. Okay, now using this relation, s equal to u t dash plus 1 by 2 a t dash square. Okay, here the time is t dash. Okay, instead of t we using here for t dash. Okay, here the t dash is t minus 10. Okay, substitute this value into this equation. Here initial velocity is equal to 0 and t dash equal to t minus 10 plus 1 by 2 into the acceleration is 1 meter per second squared. Okay, 1 into t minus 10 whole square. Okay, now 0 into anything is equal to 0. Okay, 0 plus 1 by 2 into t minus 10 whole square. Okay, further resolve this equation 1 by 2 into here using a plus b, sorry, a minus b whole square formula, a squared plus b squared minus 2a b. Okay, that equation only used here. So t squared plus b squared is b is 10 here. So 100, 10 square is equal to 100 minus 2ab, 2 into a t into 10, so 20 t. Okay, this is equation 2, this is equation 1. Now equating the two values of s. Okay, this is s equal to 10 into t. This is s equal to 1 by 2 into t square plus 10 100 minus 20 t. Okay, equating two value of s, equation 1 and 2. Now we get the 1 by 2 into t square plus 100 minus 20t equal to 10t. Okay, now resolve this equation. This 2 is come to this side, so now we get t square plus 100 minus 20t equal to 20t. Okay, now this 20t is come to this side. Now we get t square minus 40t plus 100 equal to 0. Okay, now using this resolve this equation, quadratic equation, you will get the value of time. Okay, uh, here uh, we are using the quadratic equation. What is quadratic equation? B plus or minus b squared minus 4ac divided by 2a. Okay, here a is 1 and b is 40 and c is 100. Okay, so b value is 40, 40 plus or minus square root of b squared, 40 squared minus 4, 4 into ac, a value is 1 into 100. Okay, divided by 2 into a value is 1. Okay, resolve this equation. Finally we get the two speeds. Okay, uh, two times. Okay, one is 37.32 second and 2.68 second. Okay, uh, now we go. The time 2.68 second is impossible because the gp start after the 10 second only. Okay, okay, already the gps start after the 10 second only. This the time is below the 10 second. 2.68 second means this is below the 10 second. So 2.68 minus 10 equal to minus 7.32 second. So this gives the absurd result. Okay, uh, it is not possible. Okay, now we go for the second uh, time. The time necessary for the jeep is to catch up the smuggler car is given by t dash equal to t minus 10 second. Okay, because this is the total time. Okay, to cover the distance. Yes. Okay, this is the time is total time taken for cover the distance. Yes. Okay, from the police station to that final police catch the smuggler point. Okay, now the what is the question is the find the time necessary for the jeep to catch up with the smuggler car. Okay, the police team time necessary to catch the smuggler car. Okay, this is the question. So t dash equal to t minus 10 second. Okay, 37.32 minus 10 second. We'll subtract that 10 second. Finally, we got the 27.32 seconds. Okay, the police jeep is catch the smuggler car within the uh, 20 at the time of 27.32 second. The police car will catch the smuggler car. Okay, thank you, student. I hope you understand this both the problem. Thank you. Is there any doubt? Come on to come on to me. Okay, thank you so much.